Welcome to Lesson 2.2, Analyzing Conditional Statements. When I started teaching geometry last year, I actually felt that in the entire book, this lesson was the most confusing because it really does not involve a lot of math. It involves a lot of logic thinking, and there's a lot of words that you need to get used to. So a conditional statement is basically a logic statement that has two parts. It has a hypothesis and a conclusion. And when you get into this and you get into higher levels of logic, the hypothesis, they're going to use the letter P, and the conclusion, they're going to use the letter Q. So it's written in if-then form. So if it is raining, so that's your hypothesis, if it is raining, then there are clouds in the sky. And that's pretty true. If it's raining, we have to have some clouds in the sky for the rain to fall off of. On these problems, I believe you can do this. Certainly you can do these. On these, classify each of the following angles as acute, right, or obtuse, and then find the complement and the supplement of x, y, z. You can do that. Now, this last one gets into a little bit of logic. If xy is equal to yz, is y the midpoint of xz? So if I have a diagram like this, and I have x and I have z, if xy is congruent to yz, then obviously y is a midpoint, but can we come up with another way that we could draw this picture and have y not be? Well, they did not tell us that x, y, and z are collinear. So therefore, I could draw a triangle here. I could have x, z, and I could have y up at the top here, like a triangle. And then I could have a situation where xy is congruent to yz, but y is not the midpoint because they did not tell us that x, y, and z are collinear. If they said x, y, and z are collinear, or all on the same line segment, then obviously y would be the midpoint, but they did not tell us that. So that's the very beginning of logical proof thinking here. And we're going to need to keep those kinds of pitfalls in mind as we get further in our geometry studies. So we talked at the very beginning before the warm-up about if-then statements. So all birds have feathers. So to write that as a if-then statement, if an animal is a bird, then it has feathers. Two angles are supplementary if they are a linear pair. So in this case, if two angles are a linear pair, then they are supplementary. So they took this if part, that's the hypothesis. If they are a linear pair, then they are supplementary. Talked about this briefly in chapter 1. Just because two angles are supplements doesn't mean they're a linear pair, because if you remember, you could have two angles that are supplementary but are not, not adjacent, so they might not be a linear pair. But if they are a linear pair, then they are supplementary. It just doesn't always work in reverse, and we're going to get into that in this lesson. So first of all, let's just talk about putting things in if-then form. All 90-degree angles are right angles. So if an angle is 90 degrees, then it is a right angle. If the measure of an angle is 90 degrees, then it is a right angle. Now in this case, if it's a right angle, then it's 90 degrees, still would work. 2x minus 7 equals 1 because x equals negative 3, so this is our hypothesis. We are assuming this to be true because we have told this. If x equals negative 3, then 2x plus 7 equals 1. Now, if 2x plus 7 equals 1, then x equals negative 3, so that would work also. When n equals 9, n squared is 81. So if n is 9, then n squared is 81. Now, would this work the other way? If n squared is 81, then n equals 9. In this case, that's not true because n could be negative 9. And we'll get into that later. Right now, we're working on just writing this as a true if-then statement. Sometimes they work in reverse. Tourists at the Alamo are in Texas. So if tourists are at the Alamo, then they are in Texas because the Alamo is in Texas. But if tourists are in Texas, they're not necessarily at the Alamo. There are lots of other places you can be. So you can't always work these backwards, and they still work. So let's look at some of that. Before we do that, let's actually talk about negation. Now, negation of a statement is the opposite of the original statement. So the ball is red. The negation of that would be the ball is not red. So back here, if tourists are not at the Alamo, they are not in Texas. That actually would not work because you could be not at the Alamo, but you could be somewhere else in Texas. But remember we said earlier that if a tourist is in Texas, then they are not at the Alamo? What about if we said if a tourist is not in Texas, then they're not at the Alamo? That would actually be a true statement because if you're not in Texas, there's no way you can be at the Alamo since the Alamo is in Texas. So all of these different types of ways of writing it have different words. Conditional statements are our if-then statements. Our converse is where we take the hypothesis and the conclusion and we switch them. Okay? The inverse is when we go back to the original conditional statement and we say nots. And then the contrapositive, so we flip the order and put in the negation. So it's a little confusing, but let's look at this. If the measure of angle A is 99 degrees, then A is obtuse. If I switch those orders and put the conclusion first, if angle A is obtuse, then its measure is 99 degrees. Well, that's not true. It's the converse of the statement. The conditional statement is true. Converse is not. Now, we're going to put it back to its original order, but talk about a negation. If a measure of an angle is not 99 degrees, then it is not obtuse. Well, that's not true. Just because it's not 99 degrees doesn't mean it's not obtuse. And the contrapositive goes back to our original conditional statement, flips the order, and puts in not. So contrapositive, if angle A is not obtuse, then the measure of A cannot be 99 degrees. That is true. If it's not obtuse, there is no way it can be 99 degrees. So to help you out here, there's some symbol notation. You don't need to know the symbol notation. And if you looked after this, there's a lesson on truth tables. We don't do truth tables, but there's some symbols that can help you with these. So I said earlier, for a conditional statement, there's a hypothesis P and a conclusion Q. If I switch the order and I put the conclusion first and the hypothesis second, then I have a converse statement. If I go back and take the P first and then the Q, and I use this symbol, which means negation. So the conclusion, the hypothesis has a not in it, and the conclusion has a not in it. That's the inverse. And then the contrapositive would be the conclusion first with a not, and the hypothesis second with a not. Now, when we talk about truth value, if we have a statement and the conditional statement is true, the contrapositive is always going to be true. These are going to have the same truth value. If I write a statement and this is false, then the contrapositive is going to be false. Converse and inverse are also related in whether they're true or not. If the converse is false, not meaning not true, then the inverse will also be false. It is possible to have all four true or false, but usually we end up following this pattern of the conditional and the contrapositive are true, the converse and the inverse are false. Now we are going to talk about, give you some practice, these four different types of statements using words rather than, at this point, a geometric concept. So, if you are a guitar player, then you are a musician. This is our if-then statement. It's our if-then statement, and it's also called our conditional statement. So, and for notation, this is P, this is Q. Now, for the next one, which is the converse, I would take the conclusion and it would now become a hypothesis. So the Q statement would become our P statement and the P statement would become our Q statement. I just need to change some wording here. So now I would say, if you are a musician, then you are a guitar player. That would be the statement. Then our inverse would be our original P and Q, but with negations. Negations meaning then you are not a musician, and then you are not a guitar player, and that's the inverse. And our contrapositive keeps, actually it goes back here, Q, P. So we have to change the then to if, not a musician, then. Okay, so, and let's look at whether these statements are true statements or not. If you are a guitar player, then you are a musician. That's true. If you are a musician, then you are a guitar player. Well, that's false, because if you're a musician, you could be a flute player, you could be an oboist, you could be lots of other things besides a guitar player. If you are not a guitar player, then you are not a musician. That's also false. You could not play the guitar, you could play, again, the flute or the oboe or something like that and still be a musician. If you are not a musician, then you are not a guitar player. This is true. If you are not a musician, then you do not play any musical instrument, and the guitar is one of them. So this takes you through how it was in the book, but I do use this format of breaking these up because I find it a little bit easier for students to visualize the pieces going in different directions. So write the converse, inverse, and contrapositive of the following statement. Then tell whether each statement is true or false. If a dog is a Great Dane, then it is large, which is our conditional statement. If a dog is a Great Dane, then is our large. This, if a dog is a Great Dane, is our hypothesis. That's our conclusion. So let's first talk about the converse of this statement. The converse is when we're going to switch the order. We're going to take our conclusion and make it our hypothesis. And we're going to take our hypothesis and make it our conclusion. So we have to change the words. If a dog is large, then the dog is a Great Dane. Okay? Our inverse statement would be we would keep our original P and Q. If a dog is a Great Dane, then it is large. That's our initial hypothesis and conclusion, but we're going to put in negation. If a dog is not a Great Dane, then it is not large. And for our contrapositive, we're going to change the orders of our hypothesis and our conclusion, our P and our Q terms, and put in negation. If a dog is not large, then the dog is not a Great Dane. And let's look at whether these are true statements or not. If a dog is a Great Dane, then it is large. Yes, that's true. If a dog is large, then it is a Great Dane. Well, that's false because there are other dogs that are large that are not Great Danes. If a dog is not a Great Dane, then it is not large. It's also false. Bull Mastiff is not a Great Dane, but it is large. And if a dog is not large, then it is not a Great Dane. If I'm looking at a small dog, then I know it can't be a Great Dane. So once again, our conditionals and our contrapositives are true, our converse and our inverses are false. So let's try this one. If a polygon is equilateral, then the polygon is regular. Polygon is equilateral, then it is regular. That's our conditional statement. The converse would be, if a polygon is regular, then it is equilateral. If it's regular, then it is equilateral. The inverse would be, if a polygon is not equilateral, then it is not regular. And the contrapositive, if a polygon, putting these in the wrong order, if a polygon is not regular, then it is not equilateral. So equilateral means that all the sides are equal. And if a polygon is all equal sides, then it's regular. This is actually not always true. It can have regular sides, but not it can have equal sides, but not equal angles. So in this case, this conditional statement is false. If it is regular, then it is equilateral. That's true. If it is not equilateral, if the sides are not equal, it cannot be regular. And if it is not regular, then it's not equilateral. If the polygon is not regular, it can still have equal sides. So that one's false. So once again, we have this same pattern. In this case, the conditional and the contrapositive are both false. The converse and the inverse are both true. If that's a little messy for you to read, you can read it there. I think I got ahead of myself a little bit when I was talking about the conditional, the converse, the inverse, and the contrapositive, and talking about whether they were true or false, because I started hinting at this next topic a little bit, equivalent statements. So a conditional statement and its contrapositive are both either true or both false. And then the converse and the inverse of a conditional statement are both either true or both either false. Both pairs of statements, they're called equivalent statements. In general, when two statements are both false or both true, they are called equivalent statements. Now, you can write a definition as a conditional statement in an if-then form or as its converse. If both the conditional statement and the converse are true, then it's going to actually give you a definition. For example, let's look at the definition of perpendicular lines. If two lines intersect to form a right angle, then they are perpendicular. The definition can also be written using the converse. If two lines are perpendicular, then they intersect to form an angle. Obviously, since the conditional statement and the converse are both true, the inverse and the contrapositive will also be true, and now we can use this as a definition. So for perpendicular lines, we can say if two lines intersect to form a right angle, then they are perpendicular, or we can say if two lines are perpendicular, then they intersect to form a right angle. And for your notation, perpendicular to is this symbol here. Lines L and M are perpendicular. That also means that all four angles there are going to be right angles. So decide whether each statement about the diagram is true and explain your answer using the definitions you have learned. So AC, line AC, is perpendicular to BD. That's true because we've learned that if two lines are perpendicular, they intersect and form right angles. And that's definition of perpendicular lines. Angle AEB and angle CEB are a linear pair. That's true because we've learned that if two angles share a common side and a common vertex, and their non-shared side forms opposite rays, or I think we talked about forms a straight line, then they are a linear pair. So that's true. EA and EB are opposite rays. That is not true because to be opposite rays, the two rays have to be collinear. So there goes through what we've just said. And we said that the third statement is false because they do not lie on the same line. Using the diagram, decide if you have enough information to say if the statement is true and explain your reasoning. JMF, so this angle here, JMF, and FMG are supplementary. Well, we can see that they form a linear pair, and if they form a linear pair, then they are supplementary. Because linear pairs of angles are supplementary. Use the diagram, see if we have enough information. Point M is the midpoint of FH. No, we do not have enough information. Okay, we do not know that FM is equal to MH. You can say that M is a point on FH, that would be true, but you do not know that it's a midpoint. Just because it looks like that doesn't it mean it is. Now, if we had congruent marks there, then we would know it's a midpoint. But since those don't exist, we do not know that it's a midpoint. Use the diagram shown, decide whether each statement is true. J, M, F, and HMG. Those are vertical angles. We can see that when two lines intersect, they form two pairs of vertical angles. And we also know that vertical angles are congruent. So we could even go one step further and say that angle JMF and angle HMG are congruent. Use the diagram. FH is perpendicular to JG. They don't look perpendicular, but we certainly have no information telling us that they are perpendicular. Okay? If we had a right angle symbol, or if I had congruent markings on all of these that said all of these were congruent, then they would all be 90 degrees. If there were some additional markings, we could determine that, but not from the information given here. Now we're going to talk about biconditional statements. When a conditional statement and its converse are both true, you can write them as a single biconditional statement. Once again, so it would be for definitions. If we're writing a biconditional statement, we use the phrase if and only if. Any valid definition can be written as a biconditional statement. Okay? Want to know that. So, write a biconditional. Write a biconditional for the definition of perpendicular lines. So, we said if two lines intersect to form a right angle, then they are perpendicular. And the converse of that was if two lines are perpendicular, then they intersect to form a right angle. So the biconditional, or the definition, would be two lines are perpendicular if and only if they intersect to form a right angle. So rewrite the definition of right angle as a biconditional statement. So you try and come up with one, but basically an angle is a right angle if and only if the measure of the angle is 90 degrees. So notice we have the definition that we're talking about first. The word that we're talking about first. If Mary is in theater class, she will be in the fall play. If Mary is in the fall play, she must be taking theater. So if Mary is in the fall play if and only if she is taking theater class, or Mary is in theater class if Mary is in, no, let's see how they have it written. Mary is in theater class If and only if she will be in the fall play. I wrote it the other way. Mary is in the fall play if and only if she is taking theater class. So for the given statement, write it in an if-then form, the converse, the inverse, and the contrapositive. So you could freeze this, but I'm just going to pull away the answers here. So the if-then is, if you are a sophomore, then you are taking driving lessons. Converse, if you are taking driving lessons, then you are a sophomore. Inverse, if you are not a sophomore, then you are not taking driving lessons. And the contrapositive, if you do not take driving lessons, then you are not a sophomore. We're not getting into the truth value here of these. A lot of you will actually turn 15 your freshman year and will be taking driving lessons then. Decide if the statement about the diagram is true. BD bisects ABC. Since these are congruent, BD must be the bisector of angle ABC. Determine whether the statements are good definitions. If two angles are supplementary, then the sum of their measure is 180 degrees. Okay? It should be written as if two angles are supplementary if and only if the sum of their measures is 180 degrees. But they're saying yes. If an angle is obtuse, then its measure is greater than that of an acute angle. That is, okay? The reason that's not true is because you could have an angle that measures greater than an acute angle, but is still not obtuse. So for instance, if you have one angle that's 48 degrees and another that's 53, 53 is greater than 48, but it's still not obtuse. So that's a poor definition. And here are the pages which your homework comes from.